Hello, welcome to ICCP Online Learning. For today's video, we're going to discuss Chapter 4, Improper Integrals. Let's define first what is improper integral. Improper integral is a definite integral that has either or both limits infinite or an integrand that approaches infinity at one or more points in the range of integration. Improper integrals cannot be computed using a normal Riemann integral. The definite of improper integrals, and we have three. First is let f of x be continuous over an interval of the form a, positive infinity. Then this is the formula that we're going to be followed, provided this limit exists. Number two, let f of x be continuous over an interval of the form negative infinity to b. Then following this formula, provided these limits exist. And number three, let f of x be continuous over negative infinity to the positive infinity. Then following this formula, provided that the integral of f of x dx from negative infinity to 0 and integral of f of x dx from 0 to positive infinity both converge. If either of these two integrals diverge, then integral of f of x dx from negative infinity to positive infinity diverges. It can be shown that, in fact, the integral of f of x dx from negative infinity to positive infinity is equal to the integral of f of x dx from negative infinity to a plus the integral of f of x dx from a to the positive infinity for any value of a. And this is the diagram or the illustration for us to know more about the integrations. And so as you can see, this symbol is for the integral, and 2x is for the function we want to integrate, and dx is the slices along x. And this is the illustrations for the definite integral having the lower and the upper boundary, or also called as the starting and ending boundary or points. And the f of x, that is the expression, and dx is the differential. So difference between proper and improper integrals. So when we say improper integrals, are integrals that can't be evaluated as they first appear, while you can easily integrate a proper integral as is. Integrals can be solved in many ways, including the power rule and the integration by parts. So these are the two types of improper integrals. First is the limit a or b, or both the limits are infinite. And the other type is if the function f of x has one or more points of discontinuity in the interval a and b. So as you can see, the two types of the improper integral. And first is the infinite limits of integration, and having the example of the integral of 1 over x squared and dx from 1 to positive infinity. The other type is the discontinuous integrand with vertical asymptotes. So for the example, the integral of 1 over x squared dx, and from negative 1 to positive 1. So these are the two types of the improper integral. Once again, the infinite limits and the discontinuous integrand. So for us to understand that more, let's proceed in this example number 1. So example number 1, determine whether the area between the graph of f of x is equal to 1 over x and the x-axis over the interval 1 to the positive infinity is finite or infinite. So as a solution, as we put that problem into a mathematical equation, we have A is equal to the integral of 1 over x dx from 1 to the positive infinity. And after that, we're going to form that into the limit function. So we have this one, the limit of the integral of 1 over x dx from 1 to t, wherein t approaching to the positive infinity. Seems like we just replace the infinity symbol for the t variable. Then after that, getting the integral of this function, we have the ln of the absolute value of x from 1 to t. Then applying or getting the difference of the upper and the lower boundary, and we have the ln of the absolute value of t minus the ln of 1. So as we simplify this one, okay, by getting the value of t into the infinity, okay, we came up at the positive infinity. So as a conclusion, therefore, the area of the region is infinite. So that would be our first example. Another example, find the volume of the solid obtained by revolving the region bounded by the graph of the f of x is equal to 1 over x and the x-axis over the interval 1 to the positive infinity about the x-axis. So as a solution, and as we put that problem into a equation or the mathematical equation, we came up at a is equal to the pi, okay, the integral of 1 over x squared dx from 1 to the positive infinity. So same what we did on the previous example, we formed that function or equation into limit function. So we have the pi times the limit of the integral of 1 over x squared from 1 to t as t approaches to the positive infinite. Then getting the integral of this function, we have the negative 1 over x from 1 to t. Then getting the integral by getting the difference of the upper and the lower, we have the negative 1 over x plus 1. And when we simplify that, we have pi. So as the conclusion, and therefore, the volume of the solid of revolution is pi. Next one is, how do you know if an improper integral converges or diverges? So if the limit exists and is a finite number, we say the improper integral converges. If the limit is positive, negative, infinite, or does not exist, we say the improper integral diverges. So again, when we say finite number, and when we say converges, okay, the limit exists and is a finite number. When we say diverges, the limit is positive, negative, infinity, or does not exist. So for us to understand it more, let's proceed in example number 1. So evaluate the integral of 1 over x squared plus 4 dx from negative infinity to 0. State whether the improper integral converges or diverges. Okay, so as the solution, so this is our given function, the integral of 1 over x squared plus 4 from negative infinity to 0. So putting that into a form of limits, and we just add the limit, okay, as t approaches to the positive infinite, then we replace negative infinity to the variable of t. Then getting the integral of that function, we have the arc tangent of x over 2, okay, from t to 0. And by getting the difference of the upper and the lower boundary, we have the arc tangent of 0 minus the arc tangent of x over 2. And when we simplify that to the limit of t approaches to the infinity, the answer is pi over 2. Yeah. So as a conclusion, and therefore the improper integral converges to pi over 2. And next one is integrating a discontinuous integrand. To determine if the integral converges or diverges. If it converges, evaluate the integral. If it diverges, indicate if it approaches the positive or the negative infinity. Yeah, for example, number 1, and evaluate the integral of 1 over the square root of 4 minus x dx from 0 to 4, if possible. State whether the integral converges or diverges. So this will be our solution. So same with the previous example, and we form that function into a limit function. So we have the limit as t approaches to the left of the 4 or the positive 4, and the integral of 1 over the square root of 4 minus x dx from 0 to t. Then getting the integral of that function, we have the negative 2 square root of 4 minus x from 0 to t. Then getting the difference of the upper and the lower boundary, we have the negative 2 square root of 4 minus t plus 4. Then simplifying that, using the t approaching to the left of the 4, we have positive 4. So as a conclusion, therefore, the improper integral converges to positive 4. And that would be all. Thank you and see you on our next video lecture.
For more ICCT College's video updates, please subscribe and click the notification button.